guys, so today we're going to talk about electron configurations and how to write them. So we did a reading on it, so hopefully you've done the reading. If not, go do the reading and write a summary on it. And pull out your notebook and start writing the things that I have pulled up here. I'm just going to talk about it for a second because electron configurations are really tricky and they're kind of hard. And this is something that you'll learn if you do a college chemistry class. So I want to make sure that you have some type of idea what they are, so when you go to college you're not really shocked by what they tell you. But that being said, we're not going to go really into depth. There's a lot more that you can learn about this subject. If this is something that's kind of interesting to you or that you want to know more about, you're welcome to either ask me questions or to Google or look up YouTube videos on it, because there's a lot more about this topic. But just because, with coronavirus, we're not in school a lot, and just with the length of the year and stuff like that, we just don't have enough time to cover all the details. So I'm going to be telling you some basic things about electron configurations. I'm going to tell you what it's going to look like for your test, what things you're going to need to know, and then if you want to research it more, you're welcome to do that, okay? But hopefully this will give you a basic understanding. Also, stick with me through the whole video, because at the beginning it's going to be a little bit confusing. You might be kind of confused on some of the things, but hopefully by the end of the video, all the confusion will be cleared up and you'll feel ready to do your homework and to do well on your tests and quizzes. So, the first thing that I did up here is I actually wrote out an electron configuration. So this is an electron configuration for S. And so we're going to learn how to write these today. Because there are certain things about our electrons that we know. First of all, they are what are involved in a chemical reaction. So our electrons are the things that do those reactions. That's why they react a certain way, is because of the electrons. So we talked about nuclear reactions, but we only spent one unit on nuclear reactions. Now for all of our other units, we're going to be talking about electrons, and the electrons are going to be so important. We also know that our electrons, they're found outside of our nucleus. And recently we've been talking about Bohr, and Bohr said that electrons are found in these orbitals right around our nucleus like this. But the truth is, that's only partially true. Electrons aren't just found, orbiting our nucleus perfectly. They're actually found in these things, in these electron orbitals, that are kind of a little bit crazier. They have different shapes. There's a shape that's kind of like this, or a shape that's like this. So there are a bunch of different shapes that the electrons are in. And this right here tells us which shape they're in and where these electrons are found, because they're not just found orbiting in a perfect circle. They're found moving kind of crazy around our nucleus. So we needed to tell people where they're exactly found, and that's what an electron configuration does. It tells them where these electrons can be found. So, now I'm going to start writing. There are 3 different things that we're going to talk about with describing electron location. Okay, the first thing is called an energy level. So, in electron configuration, the energy level is going to refer to the big number up front. So, it's going to be either a 1, or a 2, or a 3, or a 4, and it's going to go all the way to 7. So if you think, what else has 7 on our periodic table? You're right, it's periods. We have 7 periods on our periodic table. So each period is going to be a different energy level. We've talked about that a little bit. So these numbers, these energy levels, are what this big number is up in front right here. This is referring to energy levels. Okay, that big number up front. So 1 through 7 can be our energy level. The next thing that we're going to use to describe where electrons are located are our subshells. And our subshells are kind of the new thing that we're going to talk about. They are the letters that we find in our electron configuration up top. So there's either going to be an S, or a P, or a D, and an F. So in this class, we're actually not going to talk about F at all. Okay, but in college, they might talk about F. So I want you to know that there is F, but for this class, we're just going to be talking about S, P, and D. And these actually have different shapes. And so again, for this class, you're not going to need to know their different shapes, but I'm going to write them down to show you what shapes they have so that you can know, and if you go to college, it'll be something that's in your mind. So S's shape is kind of like this. It's just a circle. It's what we've seen. So it's saying an electron can be found somewhere in there. P has a shape like this. Okay, and that's saying an electron can be found somewhere in there, and D has a kind of crazy shape that's similar to this. And so that's what the subshells look like, and that's where electrons can be found. So then we know that this, let me zoom out a little bit. This letter right here is our subshell. Okay, so that's our 2 things. We have one more thing, and that's going to be our orbitals. So we also have to, do one of these little numbers. That's the only thing we have left to label. So this little number is going to refer to our orbital. And basically for our orbital, there's going to be only 2 electrons that can be in each orbital. So you'll notice for S is going to just always have 1 orbital. There's only going to be 1 orbital for S. P can have up to 3 orbitals, and D can have up to 5 orbitals. This is going to be really important because this tells us how many electrons can be in that orbital until it's full. So for S, in each orbital there can only be 2 electrons, so S can only have a total of 2 electrons. You'll notice up here at the top that you see the S, each time there's an S, there's no more than 2 electrons in there. You can't have 3, you can't have 4. That's just because S only has 1 orbital and it can only hold 2 electrons. The next one's P, so if there can only be 2 electrons in each orbital, if P has 3 orbitals total, we can do 3 times 2, and we find out that P can have 6 electrons total. So again, we see up here, we see when we have a P, it's never going to have more than 6. You can tell here, when it has 4, it can have less than the total, but it can never have more than, S can never have more than 2, P can never have more than 6. The final one is going to be D, and so D has 5 orbitals, so again, 2 electron per orbital, so that's going to be 10 electrons total. Alright, so that's describing our electron location. The next thing we need to talk about is rules for writing, because you guys are going to be expected to write this. You're going to have to know how to write that. And so, here we're going to give you some rules for writing it. Alright, so again, for this one, we're going to have 3 rules that we're going to talk about. The first rule is something that we're going to mention, but you guys don't need to think too much about it. Again, you can research it more if you want. But the first rule is that every electron in an orbital is going to have an opposite spin. So opposite spin in each orbital for electrons. So that's saying that, maybe, I don't know why it's not letting me put an A there. There you go. So it's saying, one electron, is spinning this way, and the other electron is spinning that way in the orbital. So if one's going one way, one's going the other way, that's how many can be in an orbital. So that kind of goes back to this rule right here, that there can only be 2 electrons in each orbital, because there's only 2 different ways they can be spinning. Besides that, you don't need to know anything else about the spin, so don't worry about it too much. So our next rule for writing is that we're always going to fill our lowest energy level first. So remember, the energy level is dealing with the 1, the 2, the 3, the 4, to the 7. So if you notice in our example up here, up at the top, we're filling up 1 first, and then we go on to 2, and then we go on to 3, and then we go on to 4. So we're never going to fill up a 3 before we fill up a 2. We're always going to fill up a 2 first, and then a 3. There are certain exceptions to this rule, but we're not going to talk about them in this class, because like I said, we're just kind of doing the basics. In other chemistry classes, they're going to talk about those, but in this one, we're always going to fill them right up in order. Okay, so that's important. Our final thing with writing electron configurations is that we're going to fill in our lowest subshell first. So remember, a subshell is relating to S, P, D, and we're going to fill up our lowest one first. So again, you'll notice up here at the top, we fill in our S first, and then we go to our P, and then we go S and then P. So like in 3, we don't do a P and then an S, we do an S and then a P. Okay, so you're always going to go in that order as you're filling in things. Also, for this, down here, there are some exceptions, but we're not going to talk about them in this class. Okay, we're always going to just do straightforward ones that follow the rule. Okay, so now we're going to go over some examples. Like I said, this is kind of confusing. I might have lost some of you. Stay with me through the examples, and then I'll show you a little trick on your periodic table, okay? But let's look at some examples first. So, let's look at the element boron. Okay, boron's symbol is B. So find B on your periodic table and tell me how many electrons it has. Okay, so boron has 5 electrons. So instead of just doing a Bohr model to tell me where they are, remember we are going to be having to write it out kind of like this up here at the top. We're going to have to be writing it like that, saying where these electrons are located. So let me kind of show you how I like to think about these. the first thing I do is I start with my lowest energy level, which is 1, and I start with my lowest subshell, which is S. Then I have to say how many electrons are in this. Remember, S can have a total of 2 electrons. Boron has 5 electrons, so there is going to definitely be 2 in S. Now, you'll notice something. I forgot to mention this, but we're going to talk about it really fast. Up here at the top, you can see that we have a 1s, and then we have a 2s. We don't have a 1p. And then we have a 2p, but we don't have a 2d yet. So these things are going to start at certain energy levels. So S starts at the first energy level. P doesn't start until the second one. And D isn't going to happen until the third one. So right here we have a 1s, 2. We're never going to have a 1p. Okay, P is always going to start at the second one. And we're never going to have a 2D. D is always going to start at the third one. Okay, so we have a 1s, 2. Then we have to move on to our next energy level because there's not going to be a P or a D that's a 1. So we went to 1, now we need to go to 2. So now we're going to have a 2. So again, we start with our lowest subshell first. So we do a 2s, and there's going to be 2 electrons found in that one. Okay, now we go to 2. We're still on the energy level 2 because remember, in our second energy level is when P starts. So now we have a 2p. So 2p, and then this, we have to be careful because we only have 5 electrons total, so we're not going to fill up our P completely. We have a 2 plus 2 so far, so we have to just add 1 more to get to 5. So P is just going to have 1 in there. So that's a little trick that you can do is always make sure that you add up these numbers, these little small numbers up top, and see that they equal your total number of electrons that you're supposed to have. So this 1s2, 2s2, 2p1 tells us boron's electrons. So that tells us where we can find those electrons. Instead of just saying it has 5 electrons, we can say it's 1s2, 2s2, 2p1. That's where we find those electrons. Okay, hopefully it's starting to kind of make some sense. Let's do another example. Okay, we're going to use sodium for this one. So Na on your periodic table. Find it really fast and tell me how many electrons it has. It's on your left-hand side. Alright, so it has 11 electrons. So let's start. Again, we start with our lowest energy level, which is 1. So we have a 1s, 2. Okay, then we go on to our next energy level. We're going to have a 2s2 and a 2p. How many are we going to put in this one? So we're going to actually put all 6. Remember, P can have a total of 6 electrons. Right here is really important, these ones. So P can have a total of 6 electrons, and we're going to have all 6 of those in there because if you notice, we have a 2 plus 2 plus 6 is 10. So we're not at our full electron level yet. So now, are we going to do a D yet? We're not going to do D yet because remember D starts on our third energy level. So we're not going to do D yet. So we went to 1, we went to 2, now we have to go to 3, our third energy level. 3, and then we start with S, remember. So now we're going to have a 3s. We have 10 electrons so far, so we're just going to have a 3s1. So sodium's electron configuration is 1s2, 2s2, 2p6, 3s1. That's its electron configuration. Alright, like I said, we might be kind of confused at this point, but now in this unit, this whole unit, we've been talking about how to use our periodic table as a model to predict things. And there's actually a trick with your periodic table that you can use. Just like with our periodic table, we could use tricks for telling how many valence electrons there are or what principal energy level it's in. You can use a trick to figure out the electron configuration. So I'm going to show you this. Let me bring up this picture up here. I'll try to make it a little bit bigger for you. There we go. So, this, on our periodic table, there are certain blocks that we can use to tell us this ending electron configuration. It's going to tell us what our very last thing is that we're going to put, so we can know what we're going to work up to. So this, right here, on this side, the first 2 columns, they're called your S block. So if anything in one of these 2 columns, it says write the electron configuration for, Mg, or any of those in those 2 columns, you're always going to make sure that it ends in an S. It's not going to end in any other thing besides S. Anything in this column is going to be an S1. Anything in this column is going to be an S2. Okay, so if I ask you write it for calcium, you can just fill it up all the way until you get to a 4S2, okay? Then we move over here onto this side, the green side, and you'll see that this is called our P block. So anything on this side is going to end in P. So you'll notice boron right here with the B, it ended in a 2p1. So anything on that side is going to be a P. So this one is going to be a P1, this is going to be a P2, P3, P4, P5, and P6. So if I tell you chlorine, if I tell you chlorine right here, you already automatically know that it's going to end in a P5. Okay? Then our middle block right here is going to be D. Oops, sorry, that's our D block. I would write this on your periodic table. I'd write what I'm writing in black, probably on your periodic table, so that you can figure it out. And so again, we're going to have like a D1 over here, D2, D3, all the way down until you get to D10 here at the end. Okay? You'll also notice that for each period is a different energy level. So you have 1, you have 2, 3, 4, 5, 6, 7. So you know, like if we said calcium, you would know that it's going to end in a 4s2. So you'd work your way to a 4s2. The only tricky thing is going to be our D block right here. And we'll do an example with D, but you'll notice D, when we're doing 4 S's, we're doing 3 Ds. Okay? We're doing 5 S's, we're doing 4 Ds. So it's a little bit different there. But now we can use the periodic table to help us figure out electron configurations of things. So let's do an example. Let's do Br as our example. Br. I think it's bromine. I'm pretty sure that's the name, but not 100% sure. So, Br on our periodic table. So, if you go and find Br on your periodic table, you'll see it's over here, right here. And we can kind of use our little trick we know, that it's on 1, 2, 3, 4. It's on our 4th period. So, it's going to end in a 4. And we also know that it's going to have a P5. So, P5. So, we know this is our ending for Br. So we know that we don't have to always count up the electrons to make sure we're not going over. We just are going to work all the way up until we get to a 4p5. So we're going to start, remember, with a 1s2. That's our starting. And then we're going to do 2s2, 2p6, 3s2, 3p6. And remember, our 3 is when we start our Ds. So we're going to go to, there's 2 different ways that you can do this. 2 different ways textbooks do it. Some of them will fill up 3D10 first, or some of them will do the 4S2 first. It just depends, whatever you feel comfortable with. Like I said, there's some more confusing things and complicated things with this. So in this class, if you write it this way, or if you write it this way, whichever way you like to works for you. So if you like to just go straight in order like this, or if you like to follow your periodic table, you'll notice we have 4, and then we have 3D that comes after. You can do it that way. But either way, you can either do this way or the bottom way. You fill up all that, and then once we're done with that row, so right now we're up to here on our periodic table. We've written up to there on our periodic table. Now we have to get to bromine, Br. So remember, ending in a 4p5. Alright, hopefully that made sense. I'll do another D1 later on to help you guys. So that is our electron configuration for bromine. So let's look at another D really fast. How about we do, let's do Fe. Okay, Fe is right here on our periodic table, so we're going to end in D. We're going to end in D1, 2, 3, 4, 5, 6. So that's going to be a D6. So that's going to be our ending. It's going to be D6. It's going to be a 3D6 is what we're going to end in. So we need to work till we get to 3D6. So we're going to start with our 1s2, 2s2, 2p6, and then we're going to do 3s2, 3p6. And so if we're moving along our periodic table like this, you notice that we get to this 4s. So that's usually how I like to write it first, is I write my 4s's first. But like I said, if you want to do your 3ds, you can do that as well. But I'm going to do my 4s first. So we're going to do 4s2. So right now I'm up to here on my periodic table. So now we need to figure all the way out to iron, Fe. And I know that's going to end in 3d6. And again, if I want to, I can count out my number of electrons and make sure it adds up to 26. Okay, those are some examples of how to do electron configurations. There's also another thing that we're going to learn for this class, is that this is kind of long. If I were to ask you to write out, an electron configuration for, oxygen or carbon or something like on the first couple rows, that's not too bad. But if I ask you to write out for something that, is down here, or something like that, it's going to have lots of different numbers and letters and things like that it's kind of confusing. So there's a way that we like to write it that's called the noble gas configuration. So the noble gas configuration is saying that we know how many electrons are in noble gases, right? So there is an electron configuration for Ne, or for Ar, or for Kr. And so you can say that this element has this electron configuration for this noble gas plus this more. I'll kind of show you what I'm talking about. So let's take bromine, for example. Let's do Br. We know that Br electron configuration is going to have a 1s1, 2s2, 2p6, like all these things all the way up to when we get to our 4s2 and 4p5. So we have to tell ourselves that we know that all of these are a certain noble gas. So for this Br's noble gas configuration, you're going to go up one row and go over to the noble gas. So for Br's noble gas configuration, you're going to go up and you're going to say it's going to be similar to Ar, but it's also going to have these extras on the end. So we're going to have Ar, and then Ar's electron configuration is going to be a 3p6 is the ending. So up until this point, this is Ar's electron configuration. So if I put this Ar up front, I don't have to write any of that because I'm saying it has all of these in it. So I just have to start with my 3d10 and my 4s2 and 4p5. So I'm just going to write a 4s2, 3d10, and then a 4p5. So that makes it really quick. So let's see, we could also do one, let's do for calcium, Ca. So calcium, if we go up one row and then we go over to the side, we see that we have Ar again. So it's going to have the Ar noble gas configuration, and then we're going to have a 4s2. So that's Ca's electron configuration without having to write out like this big long thing. Alright, we're going to do another video on this just with some more examples if you're still confused. But for your test, all you're going to have to do is I'm either going to give you an element and you're going to have to tell me what its electron configuration is, or I'm going to give you an electron configuration and you're going to have to tell me what element it is. So I definitely make sure that you label your periodic table. I definitely make sure if you're confused about this to watch the next video where I just go through some practice examples. Make sure to do your homework. Check, I'm going to put comments on them for ones that you're missing a lot. So that you can see what mistakes you're making and you can fix them. But please let me know if you have any questions because I know this is a really hard subject and so I want to help you guys out.